You're live. Excellent. Okay. Oh my gosh. Okay, so obviously, I was not here on Wednesday. Are any of you taking an AP course this year or planning on taking one in the next couple of years or something like that? Okay, you are? All right. This year, I don't know if you guys heard about it. AP testing, you know where they're doing AP testing this year? Kinda. In a trailer next to the Collins School. Yeah. So it's like you have AP, advanced placement, a college credit course if you can pass that test, and they have them taking it in this trailer next to the Collins School. You would think like, oh, we need to make sure they're in a comfortable situation, not in a trailer that used to be used for pre-K classes and was like overflow offices for for the board office. Like unbelievable. So Wednesday, when I was supposed to be here with you guys, I was proctoring an AP test. I had gotten to the trailer with the materials for the AP test around like 7:15, thinking like, okay, I'll get everything set up by 7:15. 7:30, the kids will roll in. 8 o'clock, we'll get starting with testing. It'll be great. 7:15, the doors are locked and no one can let me into the trailer. The guy who was supposed to be there didn't show up and left a message for a second guy to come and unlock the door who didn't show up. And now I'm standing there for 20 minutes while students are starting to show up and they're like, yep, this is AP testing. You're going to have rain because they can't unlock, to say the least. So it's like, yeah, but we can afford. How much did that football field cost? I'm just saying. Yet the AP students have to take it in a trailer. You got. So for those of you in the live chat, thank you for leaving your comments so far. I'm going to tell you guys what we're going to be doing today. Number one, I would like to wrap up the lessons that I've been doing with graphing these rational functions. You guys are going to get an opportunity to practice some of this stuff as we are working through some of these things together. I'm going to walk you through some things. It's going to be fantastic. After we knock that out, my main goal and focus for today. Now, listen very carefully to my words. We've been doing the pre-assessment, the remediation, the enrichment for the first standard. Today, I am going to be assigning you the post-assessment. The post-assessment you are going to be working on from about noon till the end of the class period, 12:22-ish, probably a little bit before noon, like 11:55. But it is not going to be due by the end of the class period. See, the post-assessment, they're telling us, yeah, the post-assessment, it's got to count, blah, 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 blah. I'm like, all right, but if I give them a post-assessment, which, do you remember how many questions were on the pre? Yeah, like 6. If I give you the post-assessment, and all of a sudden time is like running out, and it's getting close to 12:23, and you only have 6 questions that are multiple choice, and they're either right or they're wrong, I don't think that's fair. So I made the due date for the post-assessment for tomorrow at 11 a.m. Now, yes, tomorrow's Saturday. Yes, I understand that. Most people got it done before the end of the class period, and I told them, listen, if you get it done before the end of the class period, do not feel like you have to submit it. Don't feel like you are being forced to click submit, because you could not submit it and come back to it later in the afternoon or later in the evening, and you could take that extra time to make sure that you feel confident in what you are submitting. And, you could even take it till tomorrow morning if you can't do it tonight or something like that. But if you're just like, whatever, click, okay, that's your choice, but I'm not saying that's required of you. I want to make sure that you have the extra time to get that thing done if need be. So at about 11:55-ish, I'm going to be asking for everybody to get onto Google Classroom, both online and in person, and to begin working on that post-assessment. Again, 6 questions, link it, that whole spiel, but we'll deal with that when the time is appropriate. Yay! Fantastic. Let's see. On Wednesday, there we are. On Wednesday, I had posted something for you guys to, what's up? Oh, okay. Cool. Okay. On Wednesday, I believe the instructions that I gave was for you guys to finish any of the enrichment remediation in that page out of the book. Is that correct? Cool. I didn't want to assign anything brand new on that Wednesday, especially with a substitute. So yes, those things, I wanted to make sure you had the time to get them done. They're still outstanding, of course. We'll get that done. What you missed so far, for the intervention period, you guys are going to be knocking out the post-assessment for me today. But it is not due by the end of the class period because I don't want people to feel like they're being rushed into finishing. So I made it due for tomorrow morning at 11 a.m. So if you don't finish it in class, just don't click submit, and then you could finish it later today. Yep. I'm sorry I wasn't here.
I wasn't here either.
Oh, there you go. Yeah. The instructions for Wednesday, I didn't assign anything new. I just basically said finish up the outstanding work on Google Classroom. Yeah. Okay. So what I'm going to ask of you is kind of twofold. Number one, in a moment, I am going to ask for those notebooks to be out and to be open. But also, I'm going to ask for you to find this worksheet. Now, I gave you this worksheet, I believe, on Monday. For those of you in the live stream, this worksheet, I posted it in the Google stream on Monday. I will copy the link to that posting into the chat. Click, click, boom. So what you need out right now, sheet. It says Algebra 2 CP Rational Graphing Practice, number 1. And number 2, if you do not already have them out, oh, absolutely, I got extras. I'm going to need those notebooks out and open. Of course.
And number 2, you know that little jug you have outside that
Yes.
says your name on it?
Yes.
So I never actually looked at it, and from far away it looks like Thanksgiving colors, and I always thought it was, what are those called, a cornucopia?
Okay.
That's always what I thought it was, and I thought the little like oranges and reds and little fruits.
Did you see the wasp on its nose?
No, I didn't really like.
Go take a closer look. Yeah. Anybody else need a copy? Yep, absolutely. That's fine. I got extra copies left and right. I got extra copies. I don't know if he needs one. I'm going to leave him one here just in case. There we go.
That is the cutest damn thing I've ever seen in my whole entire life.
Yeah, a student drew that for me.
Wow, they really liked you.
Nobody likes me.
Did you try to throw this out and miss?
Every time.
It's okay. Better luck next time. It's kind of hot in here.
All right. No, I got you. I've had the window cracked most of the day.
It's freezing in some classes.
Yeah. So to go back to my previous statement about AP testing, it's just like, yeah, let's have the AP testers go into a trailer. Let's spend multi-million dollars on a concession stand in a football field, and let's not turn on the air conditioning until Memorial Day to save money. Makes perfect sense.
That's actually what they're doing. They're not turning it on until Memorial Day.
I don't know exactly when they're turning it on. I have no idea.
Some
But-
rooms are freezing and others are so hot.
Yep. Hey guys, let's not fix the air conditioning system in the school.
Yeah, weren't they supposed to pick up 2 years ago?
They're supposed to fix that probably like 10 years ago.
You think they're gonna fix it? Gosh.
I told her to fix that one.
Anyway, back to this. They'll fix it when they're good and ready, but you know what? We need to get that football field taken care of even during a pandemic. Just saying. And they did.
Just for no one to be allowed to spectate the football games.
I don't know. Today is the 7th. And this is graphing rationals continued. Now, the first little part of this is the notes that I'm going to be taking. I will let you know about this because I am going to be giving you a very important definition about holes. But first, we have to talk about how and why and when that hole actually takes place. I'm sorry. How many holes does your shirt have?
Oh, I got it. Well, it depends. Is this a trick question?
4.
Oh, I didn't know if you were gonna try to tell me that like this was like one giant hole.
Well,
like this.
think of it this way. If your shirt has a tear in it, just one single tear, wouldn't you count that as a single hole? Why not? Why would you count it as 2?
Oh no, yeah.
Yeah, just on top of the arm, let's say. Now, if there was one on the bottom of the arm, wouldn't you count that as a second hole?
Yeah.
Yeah. And then when you take that shirt off, it's like straight through.
Yeah.
Still counts as 2 holes.
All right.
Logic. So I'm on the back of this worksheet. I'm going to be going back and forth between these two, the notes and this worksheet. But I'm on the back of this worksheet, page 2 of the PDF. Again, for those of you in the live stream, I posted the link to the PDF so that you could easily access this and write this information down. But I'm looking at number 3. Now, with number 3, there's a number of things that we can do. We can attempt. Oh, he said they fixed it in winter. Anyway, we could attempt to find some asymptotes. We could attempt to find some x-intercepts. We could attempt to type it into the calculator, see what it looks like, get a table of values. But the first thing that you absolutely need to make sure, you need to factor. Factoring will determine a number of things for you. Factoring will start you on the path to getting your x-intercepts. Factoring will start you on your path to getting your vertical asymptotes. And factoring will answer the question, does my graph have a hole? Let's take a look. If I were to factor the top and bottom of this fraction, this is stuff that we've been doing since I don't even know, September. But if you factor the top of that, think to yourself, oh, 2 numbers that multiply to -12 and add up to +4, that's got to be what? X plus 6, X minus 2. That's got to work. It's got to work. Because they got to multiply to -12. They got to add up to +4. Then on the bottom, they have to multiply to +12. And they have to add up to +8. Okay. That's 2 and 6 again, but this time they're both positive. Now, after factoring, there is something that should be very, very obvious based on the factors that you have up here. What is going to happen after you factor? Does anything happen to the remaining fraction that I have written in red? I apologize, I do not. The what? Yeah, but this is huge. This is huge. They do cancel out. This is huge. The fact that they cancel out, the fact that just the x plus 6 cancels out means something huge. Let me just put a little line through them both. I'll move my camera out in a moment so you can see what the resulting equation is going to be. But this is going to be huge. This is going to mean something large for this problem. I am going to go to my calculator on my graphing, or on my computer, I should say. And I am going to type in the original equation to see what it looks like. And then we are going to take a peek at the table of values and see if we can't identify some of the important aspects of this equation. But the fact that this x plus 6 canceled out is going to have consequences. So hold on. Let me bring up the calculator here. Get rid of that. Parentheses x squared plus 4x minus 12, close parentheses, divided by, open parentheses, x squared plus 8x plus 12, close parentheses. Double checking to make sure that I typed that in correctly. Make sure you have every part of it, parentheses and division symbol. Let's take a look at the graph. Interesting. Just looking at this graph, just looking at what it looks like. That's a redundant statement. Can you identify where the vertical asymptote takes place? Can you identify the x value for which the vertical, the straight up and down asymptote takes place? Let's take a look at the equation real quick. If I go back here, the vertical asymptote, you have to set the denominator equal to 0 and solve. Now, I simplified this junk and I got it over here. If you set the denominator over here equal to 0 and solve, what value of x do you get? There you get -2. Now let me go back to my graph. And let me saunter up to the board. -2 takes place right here. That is your vertical asymptote. There's something going on, though. Not with that -2. Not with that vertical asymptote. That is going to happen exactly the way that we believe it will. But something is about to happen that is going to mess with your heads when we look at the table of values. I'll deal with the horizontal later. Let's look at the table of values. If we go to the table of values, second graph, look right there. I see an error. I see an error. Yes, an error. And that error, yes, occurs at -2, exactly where we believed it would take place. That error is the vertical asymptote. Look what I found. Uh-oh. Where does that other error occur? A -6. Wait a minute. Let's go back to the graph. -6. Listen, there was an error at -2, and that makes sense. There's an error at -2, and that makes sense. But hold on, -3, -4, -5, -6. I don't see a vertical asymptote at -6. I don't see it. There's no vertical asymptote at -6. I just circled it right there. This is supposedly where it's supposed to occur with that error. But it's not there. Let me hit trace. Let me hit trace. If I hit trace, go ahead. No, say it anyway. I didn't hear it. No, that's okay. That's okay. Check this out, though. Watch this. Watch this. Ready, 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 ready. Let me type in -2, which I know there's an error that occurs there because that's the vertical asymptote, right? If I hit enter, look at the y value. There's nothing there. It's blank. There's nothing there because that's where the vertical asymptote occurs. But now watch this. -6. Same thing. Ladies and gentlemen, we have a hole. There is a hole in the graph. Why -6? Well, ladies and gentlemen, let us go back to our notes. And let me give you some definitions and statements that are going to help define how we're going to handle these problems. If after factoring a term cancels out. Now that is exactly what just happened to us. We factored and something canceled out. If after factoring a term cancels out, then you have a hole. You have a hole. What you are to do, you are to set that term equal to 0 and solve. You are to set that term equal to 0 and solve. I know, right? I was trying to think. There was like that question of like how many holes do we have in our body, let's say, or something like that. But like technically, every pore that you have is like, yeah. Yeah, there are some animals that they do that.
Yeah, well, I don't know. If we just have like nostrils or mouths, we just like consumed everything with our pores.
You guys think that's weird. You guys think that's weird, but if that actually was the case from the beginning, you would just be used to it. You wouldn't even think it was weird. Weirdos. Anyway, the hole.
Yeah, you guys are weirdos.
Yeah, you sickos. Anyway, the hole will look like an open circle. When I say open circle, I'm referring to, do you guys remember back in the day when you had to graph inequalities and you had to have like open or closed circles? That's literally what it would be like. It'd be like an open circle. I'll show you what it looks like. It doesn't show up on the calculator graph, but when you graph it by hand, you can actually show what it looks like and where it actually occurs. So in a moment, we're going to go back to this problem number 3, and we're going to try and graph this sucker.
Can you give an example of how this would be? This is of you being like, oh, why don't you? Can you give an example of how you do this in real life?
Now, there are...
Supposed to demonstrate.
Back in Algebra 1, pre-algebra, you guys started learning like linear equations, right? Straight lines. But how often in life can something be modeled by a perfect straight line? Very few things in real life. Then you guys upgraded to higher level polynomials where you started with like quadratics. Now quadratics are a bit more real to life because those things like, they do like a curve. But even in real life, things are not always going to be a perfect quadratic. Like if I take a football and throw it, it's going to follow somewhat of a parabolic path. But there are other things that come into play. You okay? Oh, they're over here. Oh, I'm sorry. Yeah. So, because there's factors like, wind and gravity and friction and all this other stuff, So perfect quadratics are not necessarily something that models real life. I'm going to show you something on my computer, actually. So since August of last year, I have been modeling the COVID statistics for our region of New Jersey. Okay, you can see right here, since August of 2020 in the top left corner, I have been modeling the COVID statistics based on 3 categories, all the way to the most recent report that came out from the State Department of Health. I'll show you. There are 3 categories here. One of them being case rate, meaning like cases per 1,000 people. It's just our region of New Jersey. Percent CLI is the rate of COVID-like illness. Like if somebody comes in and gets tested, they don't have COVID, but they have a COVID-like illness. And then percent positivity, you get tested for COVID and you have it. Okay? Now, this one right here, this is the case rate. And now, a straight line doesn't do this justice. A quadratic doesn't do this justice. The way that this is actually being modeled is by a 6th degree polynomial. It's really messed up. But our spikes actually occurred. The highest number on this thing happened on the January 9th report, which was a January 9th report. It was the week prior, so it was like January 2nd to January 9th. That was for the case rate. And then over here for the percent CLI, the highest was about the same, about the beginning of January. And then over here, I have the percent positivity, which the highest that I have on here was actually January 2nd. Now you can see that the most recent numbers have us trending in a downward trajectory, right? But my point being is this. Straight lines and quadratics don't model real life. Higher level polynomials do. Even higher level polynomials might not be able to model real life. You might need exponential and logarithmic functions. Then when you get to something like this may be something that could potentially model real life. It's called an inverse function. A lot of the time, items have an inverse relationship to each other, and the type of curve that takes place better models something in real life. Now, those things that do end up modeling it are things that are not necessarily taught at the high school level. I'm talking like biologic features or medical features or even like stock market financial features are better modeled by higher level polynomials. Well, the hole in this particular graph, there are certain numbers that might be off limits. Like if you hit this number, something is, well, for the lack of a better term, is going to fall through, let's say, or there's going to be some kind of an error. For example, a break-even point. Let's say if this was modeling expenses versus revenue, a break-even point would just be like, okay, if we hit this point, this is the point in which we could say, well, afterwards we would be making a profit. Before we would not be making a profit. But if we're right on this number, it's just we're breaking even. There's a lot of different examples of it. But I have to continue with this. Yeah. So we got to graph this sucker. So what I'm going to do is this. By the way, are you surprised that I've kept track of like COVID stats since August of last year? Just saying, you shouldn't be. But anyway. So I'm going to have to graph this sucker. Now, there's certain things that we can identify. First and foremost, we were able to identify a vertical asymptote by taking the denominator and setting it equal to 0 and solving. We found that earlier. We can find an x-intercept by taking the numerator and setting it equal to 0 and solving. If we set the numerator equal to 0 and solve, we get positive 2. What about a horizontal asymptote? First of all, what is the degree? The degree being the largest exponent. What is the degree of my numerator, my original numerator? What's the largest exponent on the original numerator? It's 2. What about the bottom? Yay, we did it. They're equal. According to our notes, there are 3 cases for horizontal asymptotes. 3 cases. If they're equal, if the top is larger, if the bottom is larger. You have those notes. Since they are equal to each other, the degree of the top versus the degree of the bottom, your case tells you to divide the leading coefficients. The leading coefficients, which I just filled in as 1 and 1. Since that is the case, my horizontal asymptote is y equals 1. Here's what my expectation for you is for graphing these things. Number 1, factor. Number 2, identify these 3 major things: vertical, horizontal asymptotes, and x-intercepts. Something canceled out, which means we have a hole. There is going to be a hole in this problem. And according to the definition that I just gave you before, I'm going to read it one more time. If after factoring a term cancels out, then you have a hole. set that term that canceled, set it equal to 0, and solve. We're going to have a hole at -6. We'll deal with that when we graph this sucker out. I need a table of values. My table of values from right here. Cent, graph. This is where you are going to get your table of values as well. I'm going to strongly suggest that you get a couple of points to the left of the errors and to the right of the errors. A couple of points to the left of the errors and a couple of points to the right of the errors. I'm going to show you exactly what I just wrote down right there. I'm going to zoom in a little bit. Basically, from the graphing calculator, you can get all of those numbers. I'm literally just copying it down number for number from the calculator. But you got to make sure that you're getting a couple of points to the left and to the right of the errors in the calculator. Errors will occur at the vertical asymptotes and at any holes. In a moment, I'm going to begin graphing all of this stuff. I got to add all of this junk to the graph. And then I'm going to draw that smooth curve with a Sharpie. But let me start putting in these pieces. First, I'm going to put in this vertical asymptote. This vertical asymptote is occurring at -2. Boom. I can put in that x-intercept if I wanted to. That x-intercept is going to occur right here. I'm going to put in that horizontal asymptote. The horizontal asymptote is y equals +1. So I'm going to throw that in right here. There we go. Now the hole, I'm going to have to take care of the hole in a little bit. I'll come back to the hole. Let me plot these other points from the table of values, though. There's 0, -1, -1, -3, -3, +5, -4, -3. I'm sorry, +3. -5, and then 2.3, -7, and about 1.8, and -8, and about 1.67. I'll move that over so you can see where I plotted these points. I plotted these points directly from that table of values. Where's the hole occurring one more time? What x value? Which is, and I'm going to point to this actually with my fine tip Sharpie, about right there. That's where the hole would occur. And since that's approximately where the hole is going to occur, I am going to account for it with an open circle. I'm ready to draw the whole thing out. Smooth curve. Flat lining at the asymptotes. Smooth curve. Flat lining at the asymptotes. That's what that graph should look like. It accounts for everything. It accounts for where that vertical asymptote should occur, according to the equation, where the horizontal should occur, where the x-intercept should occur, where the hole should occur. And of course, the table of values is happening directly from the calculator itself. Nuts. Now, in a moment, actually in a few moments, I'm going to have you try number 4. I'm going to have you try number 4 on your own. You can use the graphing calculator that is on your Chromebook. That's up to you. But I'm going to have you try number 4 on your own, where you identify all the asymptotes, you identify any x-intercepts. But I'm going to get you started on number 4. I'm going to get you started. The first thing that you absolutely, number 1, should do on a problem like number 4 is factor. That is the absolute first thing that you need to do. And if you are going to factor, the top of the fraction should be this: x plus 4, x minus 3. Answer me the following question. Does anything cancel out? Shaking your head no. Do you know what that means? Nothing cancels. Nothing cancels. There are no holes in the problem. Since nothing cancels, there are no holes. That's how you can determine whether or not a hole is going to occur. Only if something cancels out. Since nothing cancels out, there are no holes, but you are still going to be responsible for identifying the horizontal, the vertical, the x-intercept, the table of values. What I'd like you to do, I'd like you to take the next little block of time. I want you to attempt to complete number 4. You may run into a little bit of a brick wall, but I want you to get to that brick wall. And then I'm going to help you smash through it. Let's see what you can do. Identify the asymptotes, identify the x-intercepts, identify a table of values. Oh, bless you. Bless you. If you're typing it in to the graphing calculator, I'm not going to give anything away just yet, but if you're typing it into the graphing calculator, I would strongly suggest parentheses and typing in the original. just leave it like that for now. All right. Hopefully you ran into the exact thing that I needed you to run into. Let's take a look at the graph on the calculator. Let's just take a look at this screen to see what this thing is supposed to look like. And then let's see if we can't find those pieces in the equation itself. This is what the graph is supposed to look like. This weird kind of curvy thing. I'm not really sure what's going on. Let's take a look at this equation, see if we can't pull out some of the pieces. First and foremost, if you want to find a vertical asymptote, you set that denominator equal to 0. You set that denominator equal to 0, and I get -3 when I solve it. Second of all, if I want to find some x-intercepts, I'm going to set the numerator equal to 0. What the heck's going on with these x-intercepts? What's something that you should, what conclusion should you come to when you set the numerator equal to 0 when you solve? What are my x-intercepts? Ooh. If I take a look at the graph, what do you notice about the x-intercepts? There's 2 of them. If you look at the top of this fraction, there are 2 of them. You get an x-intercept at -4. You get an x-intercept at +3. There are 2 x-intercepts to this graph. Set the numerator equal to 0 and you solve. Now, the horizontal asymptote. I'm going to write this down and then I'm going to prove to you why that is. There is no horizontal asymptote for this problem. There's none. There's no horizontal asymptote. Why is that? Here's the reason. When you look at the original equation, you should notice that the degree of the top is 2 and the degree of the bottom is 1. Since the degree of the top of the problem, the top of that fraction, has a larger degree, there is no horizontal asymptote. Instead, there is a slant asymptote. Spoiler, I have not taught you yet what the heck you do with a slant asymptote. I will be showing you that in the next few moments. How you deal with a slant asymptote. But yes, according to our definition, according to the 3 cases that you wrote down last week, if the top of the fraction has a larger degree, you do not have a horizontal, but you do have a slant. So I'm going to push this aside. Ladies and gentlemen, please return to those notebooks because I got to give you a definition as to what the heck a slant asymptote is. Slant asymptote. Now, the interesting thing, they call it slant asymptotes. I've also heard it referred to as oblique asymptotes. I like slant better. That's just my opinion. If the numerator has a larger degree, there is no horizontal asymptote. There will not be a horizontal asymptote. Instead, take the leading terms of top / bottom and divide. I'm going to show you what this looks like on this particular example. So I'll give you a moment to write that. If the numerator has a larger degree, there is no horizontal asymptote, but you will have a slant. Instead, what you are to do is you are to take the leading terms, not the leading coefficients, the leading terms of top and bottom and divide them. Example, here's the problem that we're working on. The problem that we are working on, question, what is the leading term? Hold on, someone's in trouble. Marcus' room. Okay. I'd have to check and then let you know. Yeah. Okay, got it. Bye-bye. All right. Giovanni. Mr. Peters. Let's see. Well, we're here for another half an hour. I don't think it'll take that long. Like I don't see a half an hour meeting with them, but I don't know. What is today? Here we go. Yep. There we go. Oh, take this. There you go. So I asked the question, what is the leading term of the top of this fraction? The top of this fraction, now keep in mind, not the leading coefficient, the leading term is what? Oh, that's all right. Take a guess. Neither. What? Not the leading coefficient, so it can't be 1. The leading term, it wouldn't be x either. Oh. It would be x squared. Yes. Yeah, it'd be x squared. In this case, when I say leading term, I'm pointing to the entire numerator right here. The leading term is literally just like, well, if you have it in order, what is the first term that is written? It is an x squared. On the bottom, it would be an x. So if I take the leading terms of the top and the bottom and divide them, x squared divided by x, according to my directions, results in an x. This is really weird. Y equals x is my slant asymptote. Y equals X is my slant asymptote. It is the strangest thing in the world, but I'm going to show you exactly how this works. I'm going to show you exactly how this thing is to be graphed. It's quite straightforward once you actually see it in practice. If I go back to here, I am just going to put slant asymptote Y equals X. And here's what it's going to look like. Here's what it's going to look like. Since it is an asymptote, it's going to be this dashed line. And it is going to be this dashed line that, well, it looks like the line Y equals X. It's not a horizontal, it's just basically slanted. I'm going to put my vertical asymptote in. I'm going to put my vertical asymptote in. And now all I really need is a table of values. All I really need is a table of values. I'm going to save a little bit of time. I have it written down from the other day. It's not that many points. It's like 4 points. It's -5, -4, -4, 0, which technically we already had, -2, -10, and -1, -6. I'll leave that on the board for a moment. But that is the table of values that we should be getting from this. Again, that table of values would come directly from the graphing calculator itself. No surprises about that. You just literally have to make sure you type it in correctly. Make sure it is typed in correctly into that graphing calculator. And then it's just a matter of, well, I'm just going to plot my points then. Okay. -5, -4, -4, 0, -2, -10, -1, -6. I also had an x-intercept at +3. That looks sufficient. Those are honestly all the points that I need. In order to graph this correctly, again, you got a flat line. It has to flatline against the asymptotes. And if I'm going to flatline against these asymptotes, let's see, going down this way, it would flatline. Now going up this way, notice how that graph is flatlining. It is flatlining with the slant asymptote. It is going to flatline with the slant asymptote. Don't make it curve back. Let it flatline with that asymptote. This thing's going to flatline in the vertical direction, and it is going to flatline with the asymptote going in that direction. It's going to make that turn. But it's not going to curve back. It's just going to basically follow that trend forever, going off in that direction. But that is what the calculator said it was going to be. Oh, this thing. Oh, this thing. When it comes to graphing these things, for the most part, you're going to have the calculator. You will have the calculator to help you get these things done. That is not an issue. The calculator will get done 90% of this stuff for you. It is your job to be able to identify those things known as asymptotes and holes and x-intercepts if they exist. Not today, but I will eventually, next week, have a brief assessment on identifying those things, probably throw a quizzes at you. But again, that's next week. We'll deal with that next week. Okay. The time is 11:57. What I would like to do now is I would like to transition to those post assessments that I spoke of. So I want to reiterate something about this post-assessment, especially for those that are online who may have joined a little bit late. The post-assessment is not due until 11 a.m. tomorrow. Yes, I want you to take the rest of this class period to do as much as you can on it. You don't have to submit it today. You don't have to submit it today, but you can if you want to. That is completely up to you. So you're going to need those Chromebooks out and open. And I'm going to bring this thing up on the computer. I already have the draft for the post-assessment laid out right here. And I am assigning it right there. In the assignment, you will find the link to the Linkit test taker. There is the code. That is not you. There's the code to access the assessment. Of course, your password is your student ID. This will be due Saturday by 11 a.m. But of course, like I said, you can submit it whenever you feel you're fine with it. Just in case, here's the graph of the last problem. Yeah. So you can take the remaining time of this class period to work on that assessment. I would strongly suggest that you do. Keep in mind, once you submit it, there's no going back. So if you feel like you need to spend a little bit more time on it, don't submit it, but make sure it is submitted before 11 a.m. tomorrow, and that would be phenomenal. Last thing before I stop talking, last thing. After you have submitted it, the only thing you have to do on Google Classroom is just to click that you did it. That's the only thing you have to do. You don't have to attach anything. You don't have to, create anything for it. Once you submit it on Linkit, just click to submit on Google Classroom so that I know that I can go check Linkit for your score, and then I will update things accordingly. At the end of the period, you have permission to sign out.
Mr. Markey, are you going to prom tomorrow?
Nobody asked me.
Oh, I'm sorry.
I know. Story of my life.
Yeah, are you so excited for prom? I'm so excited for prom. I'd rather go to, I'd rather take a spoon and scoop my eyeballs out the gun. Why?
This conversation took a turn.
Because I just hate dancing. I just hate it. But all my friends told me to do it. It'll be fun, they said. It's gonna be fun.
You guys still have about 2 minutes until that bell rings, but I'm going to sign off on the live stream because I got to get some things set up for where I'm going fourth period. But just as a reminder, again, that assessment is not due until tomorrow. Several people did submit it already, and that's fine. That's their prerogative. But again, like I said, I'm not forcing anyone to submit it before the end of this class period because I did not want anyone to feel like they were rushed. So please make sure you get that thing done. You have about 2 minutes until the bell, but I am going to sign off on the live stream. I'll leave it open for just a brief moment in case if you have not left a comment, so you can have the opportunity to leave that comment before I sign off. Okay. This is junior prom you're talking about? Okay, yeah. I'm sorry.